Yet another video. How exciting is that? We're doing double award, we're doing the physics, we're doing the P1, it's the higher tier. And this was one of these ones that was done in around COVID, so it was left open, so there's no real date on it. But again, I've printed this off. You can do the same in the SEA website. I have went to the bother of also printing the mark scheme because I want to have this dual with the examiner and I want to get every mark I can get. So let's start. It says name the three particles that make up an atom. There they are. Proton found in the nucleus, a relative charge. Relative means relative to the electron. So it has the same size of charge as the electron, but they're opposite. It's a positive charge for the proton and a negative charge for the electron. Same goes for mass. The proton and neutron have the same relative mass. So if you're 50 kilos and you have a friend, look at you. Well then, if they have the same mass of 50 kilos, then their relative mass compared to you is 1. The electron, as you can see, is a wee skinny fella. He's a fraction of these. 1/1836. Sometimes they accept 1/2000. But I would go for that one. So name the particles. A written communication. I'm not going to take time to write this. Capital letters, full stops, spelling's correct. The particle on, what am I looking for? For each particle stated, so the electron, and its relative charge is -1. Proton, relative charge is +1. And the neutron has no charge. Neutral, neutron. Here we go again. I've done this. If you haven't learned it, look, there's it all down there. Across zebra. Number of protons, number of nucleons, protons and neutrons, collective noun, atomic mass, atomic number. So A is the mass number. Z is the atomic number. And consider an isotope of X. There's your isotope we always talk about. The plain carbon, fancy carbon, same atomic number, different atomic mass, same number of protons, different number of neutrons. Learn it. Stop the video, have a look. Many times have I told you to learn this. Hope you're not going to be sitting in the exam saying, I wish I'd have listened to that clown and learned that. So fission and fusion are nuclear reactions. Now the fission is split, look. There's the mnemonic. Split, split. Remember the fusion would do this one. Fusion. And we do sun. That's the gases. It's the light particles. Uranium-92-238 add a neutron. This is a slow moving neutron, is absorbed by this. You get tellurium, zirconium, should have put the neutron in there. 2 neutrons, chain reaction, Diana Ross, and energy. Have you learned that? So let's answer the question. What nuclear process is represented above? It's fission. Heavy, split into 2 lighter ones. There's 3 neutrons given out. Name the particle A. Slow moving neutron. That was exciting. What happens to particle A? It's absorbed. Name a fuel represented by B. You can have uranium or plutonium. And D. These are neutrons. We slow them down and we get a chain reaction. A controlled chain reaction is a nuclear reactor. An uncontrolled chain reaction is a nuclear warhead. Look up Diana Ross. She sang about a chain reaction. Concrete block is pulled up a ramp onto a trailer. Use the information shown in the diagram to calculate the work done by the 400 Newton force. Force by distance travelled. 400 by 2 is 800 joules. 0.8. Red herring. That's Mr. Examiner, or Miss Examiner, or Mrs. Examiner. Trying to put in a bit of a rogue steer. Oh, I didn't use that. I'll have to use that. No, you don't. Work done. It was forced by distance. Have you learned this? Again, I can't keep writing these things down to learn. Have you them in a book? Have you them on the mind map? Have you the mind map printed and learned? Next one, on another occasion, 600 joules of useful work is done on a different block. The efficiency is 0.8. Calculate the total input. Remember, there's two formulas. Energy out over energy in is equal to efficiency. It has no units. Joules divided by joules. No unit between 0 and 1. If I want to change it to percentage efficiency, multiply by 100. Power out over power in. Watts divided by watts. No unit. Energy out over energy in. There's it rearranged. Look, 600 divided by that gives me that. And then see when you find that answer, you know what you should be doing? You should be doing something like this. I'll just check that. 600 divided by 750. And I get 0.8. I've got the right answer. See? Exam technique. Work on the exam. You're doing nothing else anyway. Now, next question is on a speed time graph. It would be a brother of a velocity time graph, but it's a speed time graph. So, look, speed at a certain time, acceleration, and distance. It's very similar. It's a speed time graph. It is not a distance time graph. So, be aware of that. Describe the motion of the bike during the time interval 10 to 18. 10 to 18. It's slowing down, decreasing speed. Between which times is the bike stopped? Be careful. 18. Look. Do you see the examiner? Sneaky. 21. If you glance at it, you say 20. What I keep telling you, you read a ruler. You need a ruler to read the graph. You need to slow down. The examiner has all those pitfalls sitting for you. Calculate the rate of change of speed. Remember, I told you rate means divided by time. Can't even write now. Change is the difference. So it's the speed at the end minus the speed at the start over the time taken. Read the values off the graph. 20, oh, perhaps I should say. 21, 28, look, see, 14 seconds, not 15. Time 7 seconds, told you that. 2. Last question, this one. How far does the bike travel between 10 and 18? 10, how long? 10, 18. It's a triangular shape. Look what I did in my exam technique. I wrote down the size of the base and the perpendicular height. I wrote down the formula. I typed it into the calculator. 0.5 by 8 by 10. 40. I didn't do all that work and then I'll not bother with the calculator. Work hard in the exam. Here we have a pressure question. The tank has the dimensions shown below. 0.6 by 0.4 by 0.5. Pressure equals force over area. Have you learned that? Do you know the pressures in pascals? The force is in newtons. It's a weight. Weight is a force. Area is measured in meters squared. Look at the area of the base of this tank. Length by breadth. Now there's a trick sitting waiting for a gam bean. 0.6 by 0.4 equals 0.24. Don't fall for that one. Use the calculator for every calculation. Use the information above to calculate the mass. Do you see? There's the examiner has set this trick for us. It's mass. We're going to find the weight, the force. We find the force is 1200 newtons. We have to change that 1200 newtons back to kilos. See? See the simple trick? 5 marks, that is. The tank is placed in a stand with 4 narrow legs. Has the pressure on the ground now increased, decreased, or remained the same? Well, look. If I decrease the area, I increase the pressure. They are inversely proportional. Try it with a few numbers. Do you see? The force stays the same. Big A, small b. Small a, big P. Smaller area increases the pressure if the force stays the same. P is inversely proportional to A. Next one. State using symbols the equation of Newton's second law. Resultant force equals mass by acceleration. Resultant force measured in newtons, mass is measured in kilos, acceleration measured in meters per second squared. 5 marks for that. Now if we look at the mark scheme on that one, again I have to look. Have a look. Look at that. How many times have we used that? 5 marks for that. They didn't even ask the units. Sweet heavens. 5 marks. And nice. So remember, I'll just tell you again. The first law of Newton's. Equilibrium. Balanced. Moves at a constant speed or doesn't move. Second law. Unbalanced. Not equilibrium. Resultant force equals mass by acceleration. Third law. You don't have to worry about it. Those of you that do A level, you will. I strike the puck that way. Friction always opposes motion. Now, let's have a look at this one. The puck has a mass of that. Warning. The player hits the puck with a force of 9 newtons and the size of the friction force is 0.5. Look, I've done a diagram down here. That's going 9 newtons that way. That's 0.5 newtons that way. Look at that. I've written down the mass. That's the same as the resultant force is 8.5. Resultant force is mass by acceleration. 8.5 is equal to 0.19a. See the way? I didn't even put in the case there. That just shows you. Try to rearrange the formula. Put it all in. See, do you get the answer? Take your time to study. Look at the tricks. Nearest whole number. Look at the tricks. Read the question. I got 44.73. 45. Slippy question. A mark for that. A man carries a box up some stairs. So here's up the stairs. Here's another red herring sitting ready for us. He goes up the stairs. The mass of the man is 70 kilos. When he reaches the top of the stairs, the combined gravitational potential energy of the man in the box is 1,520 joules. Calculate the mass of the box. P equals mgh. Mass is in kilos. Grand. G is in 10. You're on the planet Earth. And the height is in meters. Everything's grand. There's the KISS routine. 1,520 is equal to 20 m. Can I find out m? Take your time. Do the calculation. Now, the total mass is 76. The man was 70. So the box must have been 6. The man was 70. The total mass was 76. So the box must have been 6. Any of you that are doing these videos should recognize here's the hardest question in it. And if you haven't learned this formula, that kinetic energy is mv squared over 2, and that the velocity is the root of 2e over m, you're a gambine. This question comes up nearly every year. It's sitting waiting for you. So on another occasion, a box of 8 kilograms has a gravitational potential energy of 400 joules at the top of a flight of stairs. The box is dropped from rest and falls vertically. So the potential energy changes to kinetic energy, the conservation of energy. Do you know it? Energy cannot be created nor destroyed, but it can be changed from one form to another. 2 times the energy over the mass. Units are there for you. 5 marks for that. Let's have a look at the 5 marks. Sometimes I'd be absolutely amazed. 5 marks. Look. Have a look at that. You should have this sitting beside you. 5 marks for that. Look, they give you 2 marks for rearranging that. Sweet heavens. Now we're back again. Back to the radioactivity. Why are some nuclei unstable or radioactive? They're radioactive because they're unstable. The proton to neutron ratio should ideally be 1, and it's not. Who said so? God said so. Good enough reason for me. Here we've only got the 3 types. How many times have we done this? There's the symbol for gamma. There's the symbol for beta. There's the symbol for alpha. You should be doing this question alongside me on your blank. What would you use to detect leaks in water? Gamma, because it comes through the ground. Smoke alarms. They have alpha. Alpha is deadly if ingested or inhaled. Don't be chewing any smoke alarms. Sterilizing medical equipment. Gamma rays. And the last question. A meter stick is kept horizontal. It's in equilibrium by a force of 20 newtons acting at one end and a stretch spring. So this spring is pulling this down. The pivot acts at the midpoint. Now, what I keep telling you about these questions, you watch the distances. It's the examiner's biggest trick is the distances. And here's a classic. So I have 20 newtons acting 50 meters from the pivot. I have this force acting down. Now, I have written 40 here, but that's because I've done the question. It's that distance there I want in the calculation, but they want that distance in the answer. Do you see that? So the spring is a spring constant of 6.25 newtons per centimeter. So to stretch this spring, you do a force of 6.25 newtons. See, it tells you 6.25 newtons stretches it by a centimeter. And it's been extended by 4 centimeters. 6.25 by 4 centimeters is 25 newtons. So that is pulling down with a force of 25 newtons. Your advice you show you're working out. So 6.25 newtons extends the spring by 1 centimeter. So 6.25 by 4. 25 newtons extends the spring by 4 centimeters. Now, they mightn't just accept that. I don't know how many marks is for that. 2, have a look at that. F equals KE. Allow F equals KX. 6.25 by 4. So I'll just write that in. Hooke's law. Force is equal to the spring constant by the extension. So the force is 6.25 by the extension is 4. And always be wary of the examiner and the extension. Because he give you a new length and the old length and work out the extension. 25 newtons. Now we need to find the force. Some of the clockwise moments and some of the anti-clockwise moments. 25 by question mark. Force by perpendicular distance from the pivot is equal to force by perpendicular distance from the pivot. Tidy up a bit. So that distance works out 40. But don't forget, the examiner is not your friend. They want that one. We know that that's 50. I keep telling you, they're not your friend. We have worked out the distance from the pivot is 40, so that's 10. See the slippy one at the end. How many marks, what do you get for it? You lose a mark if you don't get 10. Read the question. So let's get back to where we are. Have you that printed out? Are you working along with me? I've tried to speed these videos up a bit. Have you the mark scheme? Are you listening to my explanations? Are you listening to the pitfalls that I'm trying to explain? We'll go again sometime later. Goodbye.